Today we will be looking at notes to exponential and log applications. At the top of your notes are the formulas that we will be using for the next 5 problems. So in problem number 1, let's read it out, and I'm going to highlight the important numbers and information. So for your 16th birthday, your parents offer you $8,000 to purchase a used car. You can either take the car or invest the money into the school credit union. Currently, a student Boom CD earns 4.88% interest compounded daily. If you left the money in this account until you were 70 years old, how much would it be worth? And so when we look at which formula are we going to use, we're going to look at our 3 rows. Okay, so it's not about general growth or decay. So then we're looking at our 2 interest rows. And so this problem doesn't say it's continuously compounded. So we will be using the last one, A equals P times 1 plus R over N raised to the NT. And so when we look at that, A stands for the final amount. We want to find the final amount. P is the initial investment or principal. So that initial investment is the $8,000 that your parents are offering you for the car. R is the annual interest rate, but in decimal form. So R is 4.88%, but in order to get that in decimal form, think of it as moving this decimal over twice. So in decimal form, that's 0.0488. N is the number of times it's compounded per year. And so it's compounded daily. We can just say 365 days in a year. And N is so that's N. T is the time in years. So you're starting at 16, ending at 70. Do 70 minus 16. That money will be sitting for 54 years. So knowing all of this, we now have our P, our R, our N, and our T, and that's all we need in order to find A. So what you're going to be putting in your calculator looks like this. So 8,000 times 1 plus our R is 0.0488. And our N is 365. That's being raised to 365 times 54. And so I'll be using Desmos. You can use whatever calculator you have. So I'm going to have, using parentheses, it's 8,000 times 1 plus, and I'm going to make that a fraction, 0.0488 over 365 days, and that is being raised to 365 times 54, and we get this number. Our final amount is 111,549 and 16 cents. So think of terms of money. That will be your final answer. So let's look at number 2. In number 2, we're not dealing with money or interest. So we're actually going to be looking at the first row of formulas for general growth and decay. And in this problem, we have the element iodine 131. It's used in the treatment of hyperthyroidism. The half-life of iodine 131 is 8.0545 days. If a patient is given 8 millicuries of iodine 131, how long will it take for the iodine to decrease to 0.1 MCI? And so when we're talking about decay here, so it's asking how long will it take for the iodine to decrease or to decay, we're going to be using this first formula. A equals A naught times R raised to the T. And so let's try to take out the information from the problem. Our A, or our final amount that we are trying to see how long it will take to get to that amount, is 0.1 MCI. Our initial amount, or our A naught, is the 8 MCI. When we're talking about rate, we have to look at, well, up here it's saying, well, if R is the rate, when we're talking about something doubling, our R is 2. When we're talking about something decreasing by 20%, our R is 0.80, right? So 100% minus 20%, that's 80%. So we're talking about half. So how long will it take to be cut in half, right? And so our R is going to be 0.5. So let's write that all out. Our R is 1/2, or 0.5, and T is what we're looking for. We're going to be using this later. So on your notes, it will say that T is equal to the time or equal to number of repeats. So that 8.0545 days is going to come in later. But for now, we have enough information to take the numbers we have, plug it in to that formula there. So I'm going to have 0.1 is equal to 8 times 1/2 raised to the t. So we're going to solve this exponential equation for our t up here. So our first step, the 8's not being raised by the t. So those two things are multiplied. We need to divide by 8. So 0.1 divided by 8, you get 0.0125. And that 1/2 is being raised to the t. So if we want to solve for the variable t and it's in the exponent, what I'm going to do here is take the natural log of both sides. I'm just going to say that natural log, I'm going to make that 1/2 a 0.5. And remember, there is something called the power rule for exponents. And that means if that t is up there, when we take the natural log, we can bring it out in front as a coefficient. So now in order to solve for t, we need to divide both sides by the natural log of 0.5. And so we're going to put that into our calculator. We're going to get some number for t. So if you are using Desmos to get natural log, you're just going to go to functions. It's in miscellaneous. So I'm going to take the natural log of 0.0125, close my parentheses, then divide that by the natural log of 0.5. So my t is 6.3219. So we're not going to stop there. In this case, our t is the number of repeats, the number of times that we're halving to get to 0.1 MCI. Let's answer it in terms of days, right? So this is the number of repeated cycles. But remember this, how long do those cycles last? Well, if I multiply, let me get some more room. If I multiply 6.3219 by 8.0545. That's going to get me the number of days that it will take. And let me just write it out here. So 8.0545 times 6.3219. And I'm just going to do this. It's going to take 50.9197 days. So it might take that many amount of cycles, but the total time in the unit of days is 50.9197 days. So now we're looking at number 3. You invest $20,000 at 3.5% interest compounded continuously. When will it be worth $25,000? So we're compounding continuously. That means we're going to be using this formula, A equals P times E raised to the RT. So let's figure out what all of our variables are. So we invest $20,000. That's our initial amount, our principal. At 3.5% interest, so that's going to be our rate. And 3.5% as a decimal is 0.035. When will it be worth $25,000? Well, that's our A, our final amount. So we're actually looking for T. When will it be worth? So T is what we're trying to solve for. So let's put all of our variables, all of our numbers into the formula. So 25,000 is equal to 20,000 times E. And remember, E is a number. It's a constant. Raised to the 0.035 T. So again, once again, T is in our exponent. So what we want to do to solve this exponential equation is divide both sides by 20,000. And so we would get 25,000 divided by 20,000 is 1.25. And that's equal to E raised to the 0.035 times T. So in order to solve this exponential equation, we need to isolate T, and we can do that by taking the natural log of both sides, because if you remember, the natural log of E is 1. So I'm going to take the natural log of both sides, so this side would be natural log of 1.25 is equal to the natural log of E raised to the 0.035 T. But if you remember the log property, when we have something in the exponent, we can bring it down as a coefficient, right? So remember, ln E is just 1, so that's just 1. So we have ln natural log of 1.25 is equal to 0.035 T times 1, right? It's just itself. So if I want to solve for T, you divide both sides by 0.035. So in your calculator, here's what we're going to be putting: natural log of 1.25 divided by 0.035. So you go into Desmos. Natural log is in the functions thing. So natural log of 1.25 divided by 0.035, and we get T is equal to 6.3755, and we're talking about time, so be years. And that's your final answer for number. So number 4 is a problem that does not deal with interest. We are going to look at a colony of bacteria that grows from 10 to 200 in 1 hour. How long will it take the colony to grow from 10 to 2 million bacteria? And so we are actually going to be using this a equals a naught times the rate raised to time formula. And so when we look at this problem, what we're starting off with are a naught. In other problems, we'd call that our principal or our initial amount. We're starting at just 10 bacteria. But we want to know, well, our A, our final, we're asking about 2 million bacteria. Our rate, we actually have to calculate it. So let's talk about just per 1 hour, per hour. We would get the rate by taking 200 divided by 10 because that's the amount of growth in 1 hour. So it's 20. And we're looking for our T. How long will it take? So we're putting these numbers into that formula. That 2 million equals 10 times 20. And the 20, the R, is what's being raised to T. So again, there's our thing that we have to solve for. It's in the exponent. We start off by dividing both sides by 10. So when we divide 2 million by 10, we get 200,000 is equal to 20 raised to the T. So we could do another conversion. So this is an exponential form. If we want to go to log form, okay, so if it's a equals x to the y, how would we change that to log form? So it would be the log base x of a is equal to y, that exponent. And so what this would look like in log form is log base 20 of 200,000 is equal to T. So this is what we would end up putting in the calculator. So again, log base 20 of 200,000 is equal to T. And so this number is what our final answer will be. 4.0744 hours. So our last problem, number 5, is a little bit similar to our first problem. What we're looking at is we have $8,000 to invest for 10 years. You want to have $11,000 at the end of 10 years. If your money is compounded monthly, at what interest rate do you need to invest? So this is our first question where it's asking us to solve for an interest rate, or R. So you have $8,000. So our principal is $8,000 to invest for 10 years. Our time, it's going to be over 10 years. I want to have $11,000, so our final amount should be $11,000. And it's going to be compounded monthly. So that is our N. Compounded monthly, so the amount of times it's compounded a year would be 12. So we're looking for R. The formula that we're going to use is the one that is not about continuous compounding, but one where we have a specific N. So it's A equals P times 1 plus R over N raised to the NT. So we are trying to solve for this variable, R. Let's put in everything we know. So 11,000 is equal to 8,000 times 1 plus, we don't know R, we know N to be 12. And it's over 10 years. So I'm going to do some simplifying here. It's raised to the 120th power. So what I want to start off with is dividing both sides by 8,000. So that 8,000 is not being raised to that power. We're trying to isolate the base, whatever is being raised. So it's 11 over 8 is equal to 1 plus r over 12 raised to the 120. What we're really doing here, if we want to get this expression, that stuff in parentheses by itself, we need to take the 120th root of both sides. And so on this side, it will just leave us with 1 plus r over 12. But let's look in our calculator. Using Desmos, we can get the 120th root by going to functions and then look for the thing that has an nth root. So I'm going to pick this. So I can put 120 there and 11/8 inside. And so this is what we get. I'm not going, you don't necessarily have to find this number, but this is what you're doing. So 120th root of 11/8 is equal to 1 plus r over 12. We need to get the r by itself. So I need to subtract 1 from both sides. So it's the 120th root of 11/8 minus 1 is equal to r over 12. Still not isolated, but we would want to multiply both sides by 12. So again, I'm going to write it over here. So r, once I multiply both sides by 12, it's isolated and I get 12 times the 120th root of 11/8 minus 1. Let's just put all of that in our calculator. So 12 parentheses, we want the nth root, and that n is 120. 11 over 8 minus 1. Okay. So r, we get this decimal, 0.0318. We'll truncate to 4 decimal places. But it's not asking for the decimal. When we talk interest rates, we're talking about percentages. And I'm actually going to go, I'll go one more place. So we're talking about percentages. We're going to convert that decimal to a percent. 3.188% is going to be our final answer. That is the interest rate that you would need to invest your $8,000 at to get $11,000 by the end of those 10 years.